Hello, 8th graders. Hope you're having a phenomenal Monday, or whatever day of the week you happen to be watching this on and listening. But today we're going to be comparing functions. So I know in the past we've talked about what is a function, and we've done some graphing stories about functions. Today we're going to compare functions. And our functions might look similar, like these two do right here, because they're both in a table. Our functions might look different. So regardless of what they look like, we're going to try to use our knowledge about functions to figure out, maybe some rate of change, problems for today. So let's take a look at these two functions that we see right here. Again, they're both tables, and it asks us to make a couple statements that are comparing and contrasting these two tables. Well, obviously they're both tables, so we can't say that yes, they're both tables. But let's call, I guess, let's just say the one on the left here gets to be table 1, and we'll call this one over here table 2. Okay, I would say if we're going to compare these two, well, we know, yes, of course, they're both tables. They've got x and y values in here. If we say table 1, if I can write on here, there we go, table 1, when we look specifically at table 1, it looks like our x values keep going up by 2 each time. Alright, if we glance over at table 2 and see what's going on, it looks like our x values are going up by 1 each time. Interestingly enough, let's look back at table 1's y values. Its y values go up by 4, right? Each 4 plus 4 is 8, 8 plus 4, 12, 12 plus 4, 16. So here I could say, like, hey, our x values are going up by 2. Here our y values are going up by 4. We already said on table 2 our x values are going up by 1. What are our y values doing? Our y values are going up, interestingly enough, by 1 as well. So I can say table 1 and table 2, right? Well, they're both going up by different numbers. They're both going up the same amount in each table, right? So I'll say table 1 and table 2 both x and y values, I'll say increase at a constant rate. Increase at a constant, that's a terrible constant, rate. And when you think rate, or when you hear that word rate, what other word might come to your mind? I also think of slope, because we think rate of change, right? Rate of change means slope. We're going to be talking a lot about that today. So we compared them there. It looks like they're both tables go up at a constant rate. Yes, I know they're different rates. Well, maybe that's where they differ. So let's figure out the slope of table 1 and table 2, and I'm assuming they're probably going to be different. So we can do that. If I wanted to figure out the slope of table 1, again, y2, 8, minus y1, 4, over x2, 4, minus x1, 2. 8 minus 4, 4. 4 minus 2, 2. Interestingly enough, those happen to be these two numbers. So I'd say table 1 has a slope of positive 2. Figure out what table 2 is. 4 minus 3 over 2 minus 1. 4 minus 3 just 1. 2 minus 1 is 1. Again, don't leave it as that fraction 1 over 1. Simplify that down. So table 2 has a slope of 1. So that's how they differ. They both, again, if we were going to compare them more, we could say they both have a positive rate of change, or a positive slope, but they both have different slopes to them. All right. What if we see two graphs? All right. Look at the two graphs that we've got here. What do we know that's the same about them? What do we know that's the same about these two graphs here? Again, if you want to take some guesses, feel free to pause the video and take some guesses on these. I would say one area that they're both the same, right, is, let's say both have a, I'm just going to say positive slope. Remember, we have 4 kinds of slope: positive, negative, 0, undefined. Both of these graphs show me positive slope. That's really about it. They don't really go through any of the same points, ordered pairs. I think one of these graphs is increasing at a quicker rate. To figure that out, maybe we find slope of these two graphs. So let's zoom in here on this graph. Let's pick a couple good points. Find its slope. I'd say this seems to be an appropriate point, and let's find another good point. How about this one right here? I think we could also use this point right here. Again, any of these points, we should be pros at this. We're going to go up, we're going to go to the right, so we're going to go up 2, positive. We're going to go right 3. Again, there you go. So slope of this graph is 2/3. All right, let's take a look at the graph here on the right. Again, pick some good points. All right, that looks to be a good point, and that does as well. And I'm guessing this one down here should look pretty good too. Again, I know the slope's positive. Just to be different, I'll start here. I will go down, then I will go left. Both down and left are negative moves. Here I've got, I go down 1, 2, I go down -3. That leaves me here. Then I go left 2. All right, so this is -3 over -2. We can simplify that to say 3/2. Okay, so there's our two graphs. We figured out their slope. How are they alike? They both have positive slope. How are they different? It's similar to our tables. We see different slopes, but let's take it one step further. Let's not just say that they have different slopes. Let's say, hey, this graph has a higher rate of change, or a greater rate of change, I guess is a better way to say that. So we'll call this graph A. This gets to be graph B. And I will say graph B has a greater rate of change, or you could put a greater slope. Maybe we'll just put all that on here. Slope / rate of change. And I've got great news for you, as if I haven't given you enough good news already today. We don't necessarily need to figure out slope in order to determine which one has a greater rate of change. Yes, we can do that, and the higher number wins out 2/3 versus 3/2. Right? This is, if you think of them in decimals, this is 0.6 repeating, this is 1.5. So the larger number is the greater rate of change. Or you can look at the steepness of the line, right? I could also have easily have said graph B is a steeper line. And steeper line means it has a higher number with its slope, a larger number with its slope. Okay, it's increasing at a faster rate. So there we go. So there's, when we have two graphs, we can compare their lines, all right, and look specifically at which one is steeper. If you're steeper, you've got a higher rate of change, which also means slope. Good news, 1 page down, only 2 to go. It's pretty exciting, I know. All right, so now we're going to throw a couple things at you. So now we're not going to give you the same thing anymore. Now we've got one of each. Now I've got a table, now I've got a graph. But it's still pretty easy to compare these two things, right? And so here's what I would say we should look for. So I've given you a couple hints over here. So things to look for when I want to compare tables and graphs. The obvious one that we've talked about is, of course, slope. So we could definitely look at that. We can also look at direction, right? What are we? When I say direction, what am I referring to? Again, we've got four kinds of slope: positive, negative, zero, undefined. Right? We're talking about the direction of the line. Slope. I'm going to give you another hint. Let's think steepness. Awesome. Okay, so now here's our graph. Here's our table, and it says make two statements about these two. Okay. Well, again, I know I can think about slope. So maybe, if you want to pause the video and figure out the slope of these two, you can. Go ahead and do that. If not, I'll figure out the slopes of these two on my own here. Okay, so table, again, 2 over 1, 2 over 1. All right, this turns into 1 over 1, so this has a slope of 1. All right, what about our graph? Our graph over here doesn't appear to be as nice. It does go through this point. It looks like it goes through the origin, guys. And it looks like it goes through this point down there. Looks like it goes through this one up here. Figure out slope for any of those points. We will go up, then we will go right. So it looks like this goes up 3 and right 4. So slope of this one is 3/4. Slope of the other one was 1. So now we can make some statements. We can make really a lot of statements. I would say both have positive slope. Okay. Interestingly enough, if we were to graph our table over here, we would see, and you know what? Why don't we just do that? Let's do this. So I'll just cheat. I'll use this graph right here since it's already made, and I'll use the points over here. So this we had 1, 1. All right, 2, 2, 3, and 3, and 4, and 4. And again, not a bad strategy, guys. If we need some help and we're not sure. That's a wavy line. That's pretty sweet. Okay, so now maybe I'll just there. That looks awesome now. Maybe now it's easier for us to compare these two things now that they're on the same graph together. Easy to see that yes, they both have positive slope. All right, they're both going in the same direction. They both increase from left to right. Can I say which one is steeper? I can, and we could have concluded that just by looking at their slopes, 1 and 3/4 and comparing them, right? But I can say the table has a greater, again, slope, rate of change, steepness. All of these work. Interestingly enough, they both go through the origin as well. That's 0, 0. All right, so lots of good things we can say about those two. Here's a couple more tables, a couple graphs. Actually, now it wants us to circle the function with the greatest rate of change. Draw a box around the function with a smallest rate of change. Okay, well, in order to do that, we need to figure out rate of change for each one of these things. So if you want to pause it and do that, go for it. if you're still struggling with finding slope, you can hang out with me and we'll figure this. Okay. All right, let's figure out slope of this line here. So we need to pick some good points. I believe that to be a lovely point, and so is this one right here, and so is that one. All right, I've got enough here. We're gonna go down and right. This one shows me negative slope. It goes down 1, it goes right 3. So slope of this one is negative 1/3. Okay. Moving over to our table. Again, we can use our formula to help us with this. Y2 minus Y1. So Y2 minus, be careful, Y1 over X2 minus X1. Double negative really turns into addition, negative 2 plus 1. So this is negative 1 over 1. All right, so the slope of our table here is negative 1. All right. Another graph over here. Again, pick some good points. I think this point right here looks to be great. And I would also say this point right here appears to be great. I think that's about it. Let's go up, and then we will move to the right. So we're going to go up 1, 2, 3, 4. So that's a positive 4. We go right 1, positive 1. So slope of this line is 4. And our table here. Let's finish with this. Again, formula again says y2 minus y1. So 2 minus 1. And that's over 6 minus 1. So 2 minus 1 is 1. 6 minus 1, just 5. So this has a slope of 1/5. Okay, so now we can compare. Right? Again, we're just talking about rate of change. Rate of change, synonym for slope, all things fun. I need to draw a box around the function with the smallest rate of change. I need to put a circle around the function with the greatest rate of change. Now, we haven't seen this before. What looks different about these when I'm comparing all of these numbers? I've got negative ones in here. Don't make the 8th grade assumption of, oh, hey, negative numbers are smaller, so the smallest one has to be a negative number. Right? That is not true at all. Right? If we pick the smallest number on here, that would be negative 1. Right? Negative 1 is actually smaller than negative 1/3. Right? Think about a number line. Which one of those numbers is closer to 0? Right? The further away you get from 0, the smaller you get to be when we're thinking negative numbers here. Okay, that's not true. So we want to think about their numbers, almost think about their absolute value of their number, right? The absolute value of negative 1/3 is just 1/3. The absolute value of negative 1 is just 1. If that's easier for you to think about, let's do that. I think it's obvious which one of these is the greatest rate of change. So we're going to make the greatest rate of change with a circle. If you've got your guess, you can do that. If not, I'm going to draw mine in 3, 2, now. There you go. So there's the greatest rate of change. 4 wins out. Now, think about what I just said earlier. Draw a box, a rectangle, around the function with the smallest rate of change. Which one of these is increasing the slowest? Right? Meaning, if you're the slowest increasing one, on a graph, we would see that as a line closer to 0. Right? You'd be a horizontal line. That has no change at all. So, negative 1 is going to have a decent amount of change, just like 4 does. But now let's look at our two fractions, 1/3, 1/5. Which one shows less change? Which one shows me less change? All right, that happens to be this one right here. All right, and if you're not sure, guys, good news. Go get a graph. Go get a piece of graph paper. Graph all 4 of these on the same piece of paper, and then look at them. All right. Think about other tips, other strategies you can use if they're not giving you this information the way you want it. Okay. Here you go, guys. So now you've got some practice on your own. So we went through some of those together. Let's do this. We can skip number 1, right? That's skip. All right. We don't need to do that. Why don't you guys work on 2, 3, 4, 5, and 6? All right. Pause the video. Work through those. When you unpause the video like magic, all of the answers are going to show up on here. I'm going to pause the video as well and work through all of these problems. And when you come back, we'll be done. But here's the thing, guys. Ask questions about this stuff. If you're not sure why number 3 is the answer that it is, ask. I would also remind you, don't pause your video yet, I'd also remind you guys, did you watch this video and listen to music at the same time? I'm going to say probably not, right? You probably listened to me. So I would advise you to do the exact same thing, right? When you're working on iReady, don't think that you don't need to listen to whatever those little animated characters are saying to you, right? The stuff they're saying is equally as important as the stuff that I'm saying to you. My point is, you don't put music on to listen to me. You shouldn't do it when you're listening to them, all right? Because some of you just rush through those lessons and you don't do well on them and you're not picking up what it's putting down, kind of like what we're doing here. All right, so just a reminder for you, take your time, guys, okay? Anyway, pause this, have at it. When you come back, everything will be here. It'll be like magic. Go. Welcome back, everybody. So here's your answers on all of these. If you need to pause this so that you can go through, you can. Again, we're just finding slope in all of these and comparing them. So you'll see I represented slope by the letter M in 2, 3, and 4. Could have done the same on 5 and 6, but I didn't. Again, we're just looking for slope. So if you're not sure or if you got a different answer, again, you know, Nina and Marcus, 6.5, 7.5. We're figuring out slope on all these and then comparing them. Don't always think, though, right, like question 5. Right, this one said, who had the quickest average time per mile? So you got to do a little bit of thinking. What's faster? I'm not necessarily picking the higher number on this one, like when we're talking about greatest rate of change. Right, so a little bit of thinking there on 5. We didn't go with the biggest number, just like number 4. Right, 1 and -1 both have the exact same rate of change, although we see different slopes, 1 and -1. They show us the same amount of change over time. So anyway, any questions on these? If you're not sure how one of them is, call us over. We'll get you unstuck. All right, hope you had an awesome day listening to me in surround sound in your head. All right, go Wildcats.